Hi. So this is the desktop GUI for our open source pump control platform. And the first step we want to do is to connect the GUI, the software GUI, to the Arduino microcontroller. And how to do this is by clicking the auto connect and give it a little bit of time to load up, and then the status changes to green. Now it shows connected already, so which means the process has been completed for connecting to the Arduino microcontroller. So with this pump connected now, we can toggle on or toggle off the pump. So clicking pump on sends an activation command to the Arduino to toggle it off. You can turn it on, you can turn it off, right? And we can also set our flow rate here. Can set it to, let's just for testing purposes, let's set it to 15 microliters per minute. We can also adjust the direction by clicking the toggle button. This will adjust the syringe between the infuse and the withdrawal. Those are the two directions. So we have the different modes of the flow behavior. We have the constant, we have the pulse, we have the oscillation, we have the pulse of oscillation. So we can click on each one of them and set their flow rate, and for each one of them comes the different inputs that can be sent, that will be sent, or the commands that will be sent to the Arduino microcontroller. So for constant, it requires only the flow rate, then you apply the flow. For the pulse, it requires the flow rate, the pulse frequency, and the duty cycle. For the oscillation, requires the flow rate, the oscillatory amplitude, then the frequency as well. And for the pulse of oscillation, we have the flow rate, the frequency, the duty cycle, the oscillatory frequency, and the amplitude. These are the commands that are required by the microcontroller for each one of them. Also, the GUI has the ability for you to pause, resume, and restart the experiment. So for long-term bioreactor operations, we often need to schedule flow changes over hours or days without manual intervention, right? So without having to monitor it constantly, we have to create an experiment and schedule flow changes across hours or across days. So what we want to do now is so there's a particular button to do this on the GUI, right? So for experiment that takes longer, right, we have the experiment builder, which is the button here that lets you define a full sequence of experiments in the bioreactor across time, right? So what we want to do now is we click the button to create experiment, right, and then we'll build a sequence that demonstrates all the modes in this experiment. Now what happens is, in this modal that pops up after you create a new experiment, you will see the pump, right, you see the time, and you see the behavior of the cell or of the flow. So which we have the different behaviors, right? We have the different modes. We have the change of direction, you turn it off, you have the constant flow, you set the pulse flow at a certain time, you set the oscillatory flow at a certain time, you can also set pulse of oscillation at a certain time. So for this demo, what we are going to do now is we are going to set up different modes or different behaviors at different times. So at time 0, right, we'll turn on the pump. So that's the behavior we want to set it from this, and then you can add the step. Now the time is 0, the pump is from 0, and then the behavior is turned on, and then you click add step. Now it has added the step. So at 2 seconds, right, we can set it to, just for the demo's sake, let's set it to 2 seconds. We want to have a constant flow at 15 microliters per minute. So what we want to do now is you select the constant mode, and then you select the flow rate to be 15 microliters per minute. and then you click add step, right, and it has registered it. So the process is still going on before we do the final selection. So now the next is we want to set after 2 seconds we have this, right, and then now we want to give more time, 10 seconds. After 10 seconds we want the flow behavior to change, right, to pulse mode, right. So we select the pulse mode, and then the pulse mode requires the pulse frequency and then the duty cycles. So right now what we want to do is we set the pulse mode to be 20, or the flow rate to be 20 microliter, right, or you can leave it at 15, anyone. And then let's set the pulse frequency to be 1 hertz, right. You can set it to be 1 hertz, and the duty cycle we set it to 50%, so which is let's set it to 0.5. Now when we add the step, we say at time 0 we want the behavior to be pulse and the rate to be 20, the flow rate, the frequency to be 1, the duty cycle to be 50%. Now at 20, let's add 20 seconds, right. We want to change the mode to be oscillation mode. Now at 20 seconds, set the rate the flow to be the behavior to be oscillation mode, right, and then the flow rate can be 15, or we leave it as 20, but let's set 15 here, and the frequency can be 0. Can leave the frequency to be 0.5, and then we can say now this requires the amplitude. You can set it to be 5, and then click to add the step. And now let's also set the final mode, which is the pulse of oscillation. The pulse of oscillation, we can set it at 30 seconds. 30 seconds we have the pulse of oscillation, and then we will include, we can set the flow behavior to be maybe 20 as well. Can leave this to be 1, we can leave this to be 0.5, right. You can set the oscillatory frequency as well as 0.5, and then the amplitude we can set it to be 3, and then you click to add your step. So finally we are gonna control, because now we are not monitoring the system. So when the whole operation is done and the whole behavior is done, we want to turn off the pump, right. We want to turn off the entire system, and we are controlling it from the GUI. So what we want to do now is at 40 seconds, when everything is done, we'll turn off the pump, and now we generate the save file, right. You can save it as demo experiment.txt, right. You can save it into any folder, basically. Yeah. So now once this is done, we can be able to see in the file context mode here, you see the different steps that you have created. The instructions and commands that you are going to send to the microcontroller has been has been defined here, and then automatically the command has been saved into the txt file for the experiment that you created now has been saved into your system drive, and also it has been set up on the GUI. All you have to do now is to run the txt file. You don't need to upload anymore. So just in case you have like a default one that you probably created on your own, or probably coming from an experiment, then you can click to upload a txt file. But for this experiment that we just created, it has automatically been imported into the GUI, and all you just have to do is to click the txt file that you to run the txt file. So that's what we're gonna do now. And then we click run, and once that is happening, you'll be able to visualize it in your console. But what is happening originally now is the command is being sent to this microcontroller, and then we can see the command sent. We can see the different flow behavior picking at certain seconds. So at 10 seconds it turned it on, right? At 0 seconds it turned it on. At 10 seconds it picked the first flow behavior, which is the constant flow behavior, and after that it picked the pulse flow behavior, right? And then it picked the oscillatory, and finally it picked the pulse of oscillatory. And then when it is done, it picked it turned it off. And that's what is happening in this terminal. That's exactly how what is happening in the system as well. So the command is being sent. Now we can confirm from the GUI that the command is being controlled. The microcontroller is being controlled by the command that has been sent from this script. And with this, you can be able to resume, restart, or even pause the cycle in the process, right? So that's the full GUI real-time control with the different flow modes, and a built-in experiment builder that we have. And also it can help you to control the entire experiment in the bioreactor. Thank you.